So for part one of this problem, we're trying to find the amount of dimensionless groups that we can use in order to limit the amount of variables we have to solve for in our code. And the way we're going to do that is by using the Buckingham Pi method. So in our problem, we have a gas flowing through the tube inside, and there's liquid running out of the tube. And the 6 variables that we're concerned with right now are the mass transfer coefficient, the mass diffusivity, the velocity, diameter, viscosity, density, viscosity, and diameter. So what we're going to do here is, since we want to use dimensional analysis, we're going to go ahead and label our units for each of these variables. So Kc, which is the mass transfer coefficient, has units, meters per second. And then DAB, the mass diffusivity, has units of meters squared per second. The velocity is also meters per second. The density is kilograms per meter cubed. The viscosity is kilograms divided by meters times seconds, and the diameter is in meters. So now, since we have all of our units for each variable in place, what we're going to do is create something called a matrix. And what we're going to have is that our row up top is going to be our variables, and then on the side we're going to have kilograms, meters, and seconds. So let's go ahead and write that. So Kc DAB V density, viscosity, and diameter. And then Kg, kilograms, meters, and seconds. So we're going to set up a matrix that looks like this. And so now what's going to happen is that we're going to be looking at the power for each of the units within each of the variables. So, and then that's what we're going to put inside our matrix. So looking at the Kc variable, there's meters and seconds. So we can go ahead and say that there's no kilograms there, and we can put a 0 for the power because there's no kilograms used in the unit. And then for meters, we're going to write 1 because it's the first power since it's on top. And then for second, it's going to be -1 because it's in the denominator. And then for DAB, again, there are no kilograms. And it's meters squared, so we're going to write 2. And then for seconds, it's going to still be -1 since it's in the denominator. And then for velocity, it's going to be 0, 1, -1. And then for viscosity, it's going to be, or for density, it's going to be 1, 3, and 0. And then for viscosity, it's going to be 1, -1, -1. And for our diameter, it's going to be 0, 1, 0. So since now we have that in place, what we're going to be doing is using equation I equals n minus r. And so I stands for the number of dimensionless groups, n stands for the number of variables that we're considering, and r is the rank. And so what we'd have to do in order to find the rank is type this into our Python code using the linear algebra function from NumPy. And that has already been done for this problem. And we know that the rank is 3. So we could say r equals 3. And since we have the number of variables, that's 6, so n equals 6. n equals 6. And now we could just go ahead and say I equals 6 minus 3, which equals 3. So now since we know that there needs to be 3-dimensionless groups, we're going to go ahead and choose our dimensionless groups, like the ones that we want to isolate, the variables we want to isolate. So I'm going to go ahead and say that we can isolate our mass transfer coefficient, our velocity, and our viscosity. I choose the mass transfer coefficient to isolate because of the fact that it can only be found during experimentation. And then I want to isolate the velocity because it's the same units as the mass transfer coefficient, so it's going to be easier to solve for when later down the road in the problem. And then I choose viscosity because we need to choose another variable to isolate. So now what we are going to do is create our pi groups. And since we have 3-dimensionless groups, there are going to be 3 pi groups. So we're going to say pi 1, pi 2, and pi 3. So now what we're going to do here is go ahead and write the variables we want to isolate. So kc for pi 1, velocity for pi 2, and viscosity for pi 3. And we're going to go ahead and fill in the rest of the equation with the other 3 variables that are not isolated. So the other 3 variables are going to be d, a, b, density, and diameter. And we're going to do that for all 3 equations. All right, so now what we're going to do is assign a power to the variables that are not isolated. So for example, we're going to say DAB raised to the A, density raised to the B, and diameter raised to the C for pi 1. And then it's going to be D, E, F for pi 2. And then for pi 3, it's going to be G, H, and I. So they all have to be different exponents because they're going to be different equations, right? And the way we're going to now solve this is by looking at the units for each of these variables again, but now doing a smaller matrix per pi group. So let's write pi 1 here. So 1 equals, we're going to go ahead and say that's meters per second for kc. And then DAB is going to be meters squared per second. And then density is going to be kilograms divided by meter cubed. And diameter is going to be m. And what we're going to do here is create the same exact matrix that we did for finding the rank, but now just specifically for a pi group. So we're going to go ahead and create that same matrix again. So K, C, D, A, B, V, density, viscosity, and diameter. And then kilograms, meters, and seconds. So now we're going to go ahead and fill out this chart again, but using these specific units. And so there's 0 kilograms for kc, 1, -1, DAB is 0, 2, -1, velocity is plus atmospheric velocity, so meters per second. 0, 1, -1. Density is 1, -3, 0. And then our viscosity is 1. Viscosity is so -1. Diameter is 0, 1, 0. So now, since we have determined the units for the pi group 1, and labeled out all of the exponents, just like how we did for the rank, we're now going to create a system of equations, specifically 3 equations, in order to solve for the dimensions group for pi 1. So there are 0 kilograms in the kc unit, so we're going to go ahead and write 0. And then there are 0 units in the mass diffusivity unit, so we're going to go ahead and also write 0A. And then for density, there's 1 kilogram unit, so we're going to say 1B plus 1B. And then for the diameter, again, it's just meters, so we're going to write plus 0C equals 0. So right off the bat, there's no A, there's no C, and that's 0 plus 1B equals 0, meaning that B is equal to 0. So now we're going to analyze the meters within the units. So it's going to be 1 plus, because that's our isolated variable, and we're not raising that to any power within our pi group. So since there's 1 meter in the numerator, we're just going to write 1. And then for our mass diffusivity, it's going to be 2A. And then for our density, it's going to be minus 3B. And then for our for our diameter, it's going to be plus C equals 0. And we could go ahead and cancel out B because we already knew that B is equal to 0. So that leaves us to the equation 1 plus 2A plus C equals 0. Then for the seconds, there is a -1 because for the Kc, because the seconds is the denominator, -1 for DAB, so -1A. And then for density, it's 0B plus 0B. And then for diameter, it's plus 0C equals 0. So we can go ahead and write -1 minus 1A equals 0. And now we can go ahead and solve for A. So A is -1 because it's 1 minus 1A equals 0. So A equals -1. And since now we know A equals -1, we can go ahead and plug that into our meters equation and say 1 minus 2A plus C equals 0. And now we can solve for C. So since we know A is -1, it's going to be 1 plus 2 plus C equals 0. 3 plus C equals 0. C is equal to 3. So our C value is going to be 3. And now we can go ahead and write out the full dimensionless group for pi 1. And we're going to go ahead and write pi 1 is equal to, using those values that we calculated for our exponents, we're just going to write Kc because that's our constant. A is -1, so that's going to be in the bottom, so DAB is going to be in the bottom. And then B is going to be 0, so there's no density in this equation. and C is 3, so our diameter is going to be up top. Oh. Diameter is going to be diameter cubed. And that's our Sherwood value. So that's SH, and that's going to be relevant in the second part of this problem. And now, since we know that velocity and the mass transfer coefficient are the same units, all we have to do for pi 2 is replace Kc with V. So pi 2 equals VD cubed divided by DAB. And that's going to be our Pleckett number. So now, since we have solved for pi 1 and pi 2, we're going to be solving for pi 3, which is going to be our third dimensionless group. So we're going to use the same exact matrix format as we did in the past, or as we did before, and we're going to write mu DAB density and diameter, and then kilograms, meters, and seconds. And we're going to fill out the matrix the same exact way that we did before. So we're going to say that there is 1, -1, -1, DAB. So it's 0, 2, -1. Density is going to be 1, -3, 0, and then 0, 1, and 0. And again, all we did was take look at the power that each of these kilograms, meters, and seconds were raised to within its specific, like the variable specific unit. So now what we're going to do is create our system of equations based off the 3 equations, and it's going to be based off of kilograms, meters, and seconds. So our kilogram equation is going to be 1 and then plus h equals 0. Our 1 plus h equals 0. Meters equation is going to be based off of -1 plus 2g minus 3h plus I, and that's going to be equal to 0. And seconds, it's going to be -1 minus g equal to 0. And so right off the bat, we can see that g is equal to -1. And then we know that our density, or so h, is going to be also equal to, -1 as well. So we already solved the kilograms equation and the seconds equation. Now all we have to do is solve meters. So it's going to be -1 plus 2 times -1 minus 3 times -1 plus I equals 0. So -1 minus 2 plus 3 equals 0. So -3 plus 3 or plus I equals 0. So -3 plus 3 equals 0, meaning that I also equals 0. So G, H, and I is equal to 0. So then now we go here and write our pi 3 equation, which is going to be our third dimensionless group. And that's going to be mu D A B and then density. And this is going to be our Schmidt number. So pi 3 equals the viscosity divided by the mass diffusivity times the density. And ultimately what we want to do is find the relationship between the Reynolds number, Schmidt number, and Sherwood number. So in order to find the relationship here, what we're going to be doing is we could divide pi 2 by pi 3. So we're going to write pi 2 divided by pi 3, which equals VD divided by DAB, and that's going to be all divided by mu divided by DAB and the density. So we can go ahead and cross out DAB there, and that's going to be equal to V times D, so velocity times diameter divided by mu and density. And so now we're going to simplify this, so it's going to be velocity times diameter times density divided by mu, and that equals our Reynolds number. And we're going to be discussing the relationship between the Reynolds number, Schmidt number, and Sherwood number in our second part of the video when we begin to code the problem.